Hello, Miss Henry's Mathematicians. We are now finished with the getting started, and we are at activity 1.1. We are still here on no substitute for hard work, evaluating algebraic expressions. We have finished the warm-up, the getting started. Now let's get started on activity 1.1. I still have my multiplication chart handy just in case I need it. I also have my scratch paper just in case I need that as well, and it is right here. And also have my highlighters and my pencil available just in case I need to color code. All right, this is a lot of words. I'm going to read it for you, but we're just going to learn a couple terms. So in this lesson, you will explore the relationship between unknown quantities by writing and evaluating algebraic expression. An algebraic expression is a mathematical phrase that has at least one variable and contain numbers in operation systems. So I want to focus on that real quick. So they said a few things. An algebraic expression is a mathematical phrase that has at least one variable, and it can contain numbers and operation symbols. All right, that's all we need to know. So each of the expressions in the empty number line activity, which is the one we just did in the getting started, is an algebraic expression. They are also linear expressions. So your algebraic expression is a linear expression. A linear expression is any expression in which each term is either a constant or a product of a constant and a single variable raised to the first power. So I don't want you to think about any of that, to be honest. What I want you to know about a linear expression is that it has at least one variable and contain numbers and operation symbols. So we're going to do a little activity real quick. And they gave us some examples of linear expressions, which include 1/2 plus 2. And I got confused, so I rewrote mine. So 1/2 plus 2. The next one they gave us was -3 plus 12.5x. The next one they gave us was -1 plus 3x plus 5/2 x minus 4/3. And then the last one they gave us was 4y. So all of these are linear expressions. Why? I want you to remember what we said that they had to have. I'm going to go back over it with you in a minute, but keep that in mind. Now, they also gave us some other expressions. They said, notice they named them expressions. They didn't say algebraic, they just said expressions. So these expressions, 3x squared plus 5, or 3x to the second power plus 5, and -1/2 y times x. These are examples of expressions that are not linear. These are not linear. So what I want you to do, and I just rewrote mine if you want to. So these were the linear examples that they gave us. These are the non-linear examples that they gave us. So what I want you to do is I want you to provide a reason why each expression does not represent a linear expression. So I want you to look at 3x to the second power plus 5 and -1/2 xy times x and y, and tell me why each one of these expressions does not represent a linear expression. Remember, they gave us a definition of linear expression, which is the same thing as algebraic expression. It's a mathematical phrase that has at least one variable and it can contain numbers and operation symbols. So I want you to tell me why these two expressions do not fit the definition of this. I want you to write your answer here, and then we're going to pause and we're going to talk about it in a minute. And then we'll continue this lesson after that. But you can go ahead and pause the video right now so that you can go ahead and answer that question. And then I will go over it with you, and then we're going to continue. But I'm going to go ahead and continue because you should be paused. So let's revisit expressions. in the previous activity. The directions did not specify the possible values for x, which means they didn't tell us what x equals. We didn't graph it, so don't worry about this. But what I want to talk about is that in mathematics, sometimes it's necessary to set constraints on values. Constraint is like a limitation where x can only be this number, or it can only be positives, it can only be negatives. So that's what I want you to think about as we turn the page and go into this next activity. Before you think about a constraint or a limitation, I want you to analyze these number lines created by Bella and Tito. I don't know where they come up with these names at. Using the expressions from the empty number line activity. If you remember in the getting started, these were those same expressions. What I want you to do is look at the constraints on each one of these representations, the limitations. That's basically what a constraint is. It's just a limitation. And a limitation is just limitation. A limit is just something that we have, we can't go over, or we can only do so much. So like, for example, a limitation with driving is you shouldn't speed. That's the limitation to having a car. You just can't drive as fast as you want to go. That's a limitation. That's a constraint. So that's the constraint. I have to follow the law if I'm going to have a car. So I just wanted to make sure we are clear on what a constraint was for each one of these. So I just want you to think about, identify the x values that make the number lines true. Or another way to think about what I'm asking you is just to analyze what is happening here. Like, what makes Bella's number line different from Tito's number line? And I want you to write it down. Do you think that who's true and who's not true? Then I want you to select the value for x from your set. And I want you to substitute that value for x in each expression to verify the plotted locations are correct. So what they mean is I want you to solve for x. So I'm going to do one for you. And hopefully you pause the video on A so that you can move on to B. So I'm going to do one of these for you. So I'm just saying I'm going to pick a number, any number, but you're going to pick a different number. But I'm just going to do an example using my number. So I'm going to pick the number 2. Just because that's an easy number. No, you cannot pick the number 1 or the number -1. You need to use a number greater than 2, but not number 2, because I'm using number 2. All right, so all my expressions are negative x, negative 1/2 x, I have 1/2 x, regular x, 2x, and 3x. So what I'm going to do is we're going to substitute. Substitute is when you replace something. So since my number, I'm saying that my x equals 2, I am going to substitute 2 for each one of these expressions. So instead of writing negative x, I'm going to write negative 2, because that's what this expression means now, because I did negative 2. If you do the number 3, then you need to substitute 3. But let me go ahead and, so now I want to do 1/2, negative 1/2 times negative 2, because that's what this is saying. The half next to the x means I'm multiplying. So when I multiply half of 2, half times 2, I'm going to put my 1 underneath. I'm going to multiply across, because that's how I multiply fractions. 1 times 2 is 2. 2 times 2 is 2. That equals 1. I have a negative times a negative. And remember, same signs. Positive. So this is positive 1. I'll do a couple more for you so that you can do it. I won't do the 1/2 and I won't do the x, because of course, since x is negative 2, then it's just, positive 2, it's just 2. It just doesn't have the negative sign in front. So now it's just positive 2 instead of negative 2. Make sure you remember that when you're going through. This one says 2 times x, which is 2. So instead of the x, I'm going to put 2. So my answer is 4. This one is 3 times, again, 2, because my x equals 2. So now my answer is 6. And then I guess I'll go ahead and do this one. I got 1/2 times 2. I'm going to change it into a fraction so I can multiply across. 2 times 1 is 2. 2 times 1 is 2, which equals positive 1. So now that I have all these values, I want to go back up here. You get your values, put them underneath whichever number line you think is correct. Or you can put them under both of them. So I knew for negative x, I got positive or negative 2. For negative 1/2 x, I got 1. For positive 1/2 x, I got 1. For x, I got 2. For 2x, I got 4. And then for 3x, I got 6. So make sure you go back and rewrite those numbers. 3x was 6. 2x was 4. X was 2. 1. 1. Negative 2. So once you do that, see if your locations are actually correct. And we'll talk about that in a minute. And then we're going to come back and do this together as a group. We're going to compare your values to your classmates. Do you have the same set of values? And what we mean by values is like, is your graph increasing or decreasing? So we're going to go back and we're going to talk about that in class. So remember, you're going to go back. You're going to describe who you think is right, Bella or Tito for A. B, you're going to select the value. I chose the number 2. You're not choosing the number 2, but I did that. You can choose something else that's greater than 2, the number 3, number 4, whatever you want to use. And then we're going to come back and we're going to compare to see whose graph was correct. And if you have like the same increasing or decreasing values. All right. Pause it here. See you in the next video. Bye.